Hello and welcome to Java tutorial number 6. Today we're going to be talking about file input-output, and next tutorial we'll be building upon what we did in this tutorial, and I'll show you how to write things like .bat files and execute them from within your program. And then from there we can take it into my quick fix, which I haven't really seen used much, if at all, aside from me using it for how to get things like system.out.println to print to the console in a compiled jar file. But again, that's probably 2 tutorials away. Today we're talking about file I/O. What is file I/O? File I/O, I/O stands for input-output. You put something in, you take something out. Basically, the way we're going to be using it today is through writing a file. However, writing and reading from a file. However, this is useful for a multitude of things, from writing files to communicating with servers to all kinds of things. So we're going to have 2 inputs today. The first import is going to be our usual java.util.wildcard. I'm going to use that for the scanner class, which you don't need with input-output, but it makes reading from files easy. That's the way I like to do it. You can also do a buffered reader in and mess with all that, but that's a little bit more complicated than I want to go right now. And the other one is java.io.wildcard, which allows us to have things like the file class, the printWriter class, and more. So import java.util.wildcard and import java.io.wildcard. Those are the 2 important ones. This is the new one. And yes, I know I haven't used it yet. So, something with this is these objects we're going to be instantiating, printWriter and scanner of a type of a certain file. By the way, scanner is not just for user input. It's used for all kinds of things, including reading from files here. However, the scanner object made from a file and a printWriter object made to a file, basically, requires that you surround it with a try-catch block. And a try-catch block I don't think I've done before. It's basically for if something happens. Like, say, for example, the most common one would be you're trying to read a file that's not there. You're trying to read file1.txt and it doesn't exist. Or you're reading in the wrong place and so it can't find it. So it throws an exception. So you need to catch those exceptions so your program can keep running instead of erroring out. It actually won't let you compile with those errors in there. So, this is how a try-catch block works. Alright, so what is, and it says unreachable catch block for IO exception. Exception is ever thrown from the try statement body. We'll fix that in just a second, because it will be. Try-catch block basically says try whatever's inside here and catch this type of exception, and if you do this. If there's no exceptions thrown, it completely skips over all of the code in here and just moves on to whatever is down here. So, we're going to try to make a printWriter. Again, capitalization is very important. PrintWriter out equals new printWriter, and we'll put it in a file called, let's do user input for it. Scanner input equals new scanner of type system.in. Alright, so we have our user input here. Then we will say system.out.println. What would you like the file to be called? Actually, I could break this up onto 2 lines. Like that. File to be called. Eclipse is nice. It automatically puts a plus sign there to concatenate the strings. Again, since I'm using a bigger font size than is generally comfortable to be using with this, it's only for tutorials that I use this font size, yours will probably all fit all the way across. But in this case it doesn't, because of the bigger font size. And then we'll make a string, output equals input.readLine. Input.next line, sorry. Readline is for buffered readers used with network communication. So, I've been doing some network client stuff lately. Input.next line, that gets whatever the next line of stuff the user input, and that will be what the file is called. We'll assume that they put .text for the purpose of this tutorial. However, if we weren't sure if they were going to put .text or not, but we wanted it to have .text, we would do if output, basically the pseudocode is if output doesn't contain .txt, append .txt to it, which would actually look like this. Might as well do it. If output.contains, contains is a method of the string class, .contains.txt, So if output.contains.txt, that means if it has .txt, this statement is true. However, this exclamation mark reverses that. So if this would normally return true, it returns false. So this is basically saying if output does not contain .txt, then output plus equals .txt. Plus equals is concatenation. It basically says output equals output plus .txt. It's the same thing, it's just shorthand. It's the same as output equals output output plus .txt. Same exact thing. You can write it either way. This is the more lengthy, more logical version. The other one is the fast version. So if output doesn't contain .txt, we'll add it because we want it to have the text extension. We could also do stuff like RTF or BAT or whatever we want. Print writer out equals new print writer, and we'll do it. We can remove these now. Output. So that'll take whatever output contains, file.txt, and it'll create a print writer called out to that file. And so whatever you print out to your out object, it'll be added to the file. One very important thing with out is to close it. You have to close it so it'll write up the file. Otherwise, it's just writing to memory, and then when your Java program closes, it's like, oh, don't need this anymore. So you need to write it actually to the hard disk by doing out.close. So print writer out equals new print writer of type out of name output, basically, of type output. And we'll also create a scanner object later on to read from the file. But let's do system.out.println. What would you like to print to the file? And again, I'll just put an enter. Put an enter there. So the first time you do an enter, it'll take you to the end of the line usually. Then the second time, it's like, oh, all right, I see what you're trying to do. And so, what would you like to print to the file? And then we'll take out. We could either make a new string or reuse output. I'm going to make a new one. String file contents, just to keep it a little bit more logical, but you could reuse output. If you said output equals input.next line, like that, then it'd overwrite whatever's in output, because you don't have the plus equals, you just have equals. So it's like saying A equals 2, A equals 4. It replaced it. It didn't add, it didn't subtract, it didn't do anything, it just replaced 2 with 4. That 2's gone. So file contents equals input.next line, and then we'll do out.print file contents. I could do println, doesn't really matter. Println would put a that at the end of the line, which is basically the almost universally accepted code for enter or next line, new line character. And so out.print, println would put an enter after that. Print doesn't put an out, a little enter after that. Either one works. And then out.close. Then we would say, and this is another reason why I wanted to use a separate one for output, I'm going to read from output. So if I reused output, I'd have to make some kind of other variable to hold the file name. So what would you like to print? And then they'll enter what they want to print, and then we'll make a scanner object, scanner from file equals new scanner. And of type, it's not system.in. System.in's the terminal input. It's going to actually be new file and then output. Now, new file is also a class of java.io, and actually has a description here. Basically, it's a file. It is, if you create a new file, it's basically a file object of that name, and if there is no file called whatever output contains in the local folder where this is running, then it'll throw you an error and say file not found exception, which is basically an IO exception. We could also remove the IO so that it catch anything that happened, and many people do that. However, many people also do multiple blocks. So e.printStackTrace you really don't have to worry about right now, and in fact that's not even necessary. It basically just prints out whatever the error was. e.printStackTrace. The stack in Java, and this is not really something I intended to cover this early, but the stack in Java is basically the Java memory stack. It's a stack of objects and creations. When you do recursion, an object creates a new object that adds to the top of the stack, then another one, another one. So you create this stack in memory, basically, and so printStackTrace is printing out basically what the stack was at that point in an error message. So don't have to worry about that right now. You could put it in, leave it out. You could even do system.out.println, an error has occurred, file not found, or whatever. IO exception has occurred, and that would also work just fine. You can do it however you want. So you don't even need anything in here. I could comment this out or even delete it. So we'll do system.out.println the file plus output plus plus contains, and then we will say, even though it's only going to have one line, this is future-proof against me adding in this program the option for the user to have multiple lines in that file. So while from file.has next line. Remember, it's a scanner object, so we can still use the same exact methods. Has next line is a new one, I think, for this tutorial, but basically it says if there's next line in there, do this. Otherwise, just move on. Move right along. Nothing to see here. So while from file.has next line, we're going to want to do system.out.println from file.next line. Now, this is also something I don't think I've covered yet. When you do .next line, it consumes that line. So suddenly the scanner object went from having, say, maybe 10 lines to 9. It consumes that line. It pulls it out. It doesn't just read it. It pulls it out. The file is unharmed. The file, a new copy has been made in memory as an object, basically, that it's pulling and deleting from. So the actual file itself is fine until you actually overwrite it. It's not deleting anything from the file. However, the scanner object is consumed as you're doing this. It consumes, when you do .next line, it deletes the next line after it reads it, because that way you can keep running and keep looking at the next line. It's actually a really nice feature, and if you for some reason need to save those lines, you can put them in an array, you can put them in a string, you can do whatever makes sense for you. So system.out.println from file.nextLine, and then at the end we could do system.out.println finished reading and finished writing to and reading and reading from file. And I will want a space here. And there's probably some other place where I screwed up with that space. Doesn't look like it. We'll see. And basically the file, I'll show you in just a second where the file is. So let's run this, see what happens. What would you like the file to be called? I want to do tutorial 6, and I will leave off .text. I'll have the program do it for me. Tutorial 6, what would you like to print to the file? This is a test file for file IO in Java. Enter. Notice this is multiple words. Notice the capitalization, notice the punctuation, notice the spacing. File tutorial6.txt contains, this is a test file for file IO in Java. It read that from the file after it had written to the file. Now, you might say, well, you know, from an outsider not looking at the source code, you could say, well, it just took my input and printed it back out and said the file contains. So we'll look at the actual file where it's located. So in here in Workspace, I have a tutorial 6 folder somewhere. It's not showing right now, but basically it'd be a tutorial folder. It'd be like tutorial 6 or whatever it is, and let's actually do a search for it. May have put it in a different folder. Tutorial 6. Oop, I'm not gonna find it if I wrote it wrong. Tutorial 6 and search. CG Miner, all that stuff. Nope, not what I'm looking for. Tutorial 6, and I'm looking for a folder, so I want to sort by type. In general, you won't have to, actually no, I'm going to search for tutorial6.java and go from there. That's faster. Find out where tutorial6.java is, then we can find where its compiled.class file is, and from there we'll be able to look at where its the actual file structure is. It's generally, well, you'll see in just a second. Once it finds it. Basically, sometimes you can also see it in here, the actual file itself. Generally, you'd have to close Eclipse and reopen for it to refresh whatever is in here. However, I think there may be an option to refresh the contents of this little package explorer. I'm not sure, but something to keep in mind. And we'll wait for the search to finish. I really should index my hard drive at some point, but I won't worry about that now. something to worry about later. As well, something to note here is with the try-catch block, you can have code in here that doesn't throw exceptions just fine. For example, systemout.println isn't one that has to have exceptions caught, and there is an alternative to doing try-catch. If you don't like the try-catch blocks, you can instead do throws IO exception, like that. So you can say that this method throws an IO exception, and that'll also work perfectly fine for running and compiling the code. Also, it says input is never closed. That's not really an issue for a memory application, for a low memory application like mine. However, it is generally good convention to close all of your objects, like a print writer. You definitely have to close to write the content of the file. However, a scanner object doesn't really have to be closed, but it can be a source of a memory leak. So let's just close them while we're waiting. Input and from file. Input.close and from file.close. Basically finalizes it, and I'm pretty sure it tells the Java garbage collector, hey, don't need this anymore. So this is in users gaming workspace. Alright, yeah, that makes sense. So users, gaming, and workspace. For some reason it's saving to someplace different. Here is tutorial 6, and if we look, here is tutorial6.txt. You see, in here is the .java file, in here will be the .class file. .class file is a compiled Java file. Basically, it's all compiled, and you can't reopen it and look at the source code unless you use a program like JDGUI, which decompiles it. However, it is a compiled file. If you are looking for a source file, that's in the src or source folder. As you can see in here, it has the contents. This is what I will be uploading to the internet for this tutorial, that file right there. And going back, here's tutorial6.java. Or .text, sorry, and inside it says this is a test file for file IO in Java. That is exactly what we put in. Now, just to prove that I didn't have this file here before, I will delete this and run the program one more time. So you can see there's no text files there. Run it, and we'll just go real quick. Tutorial6.text, or let's name it something else. Test.text. And notice we did put .text this time, and so our program will see, oh, it doesn't need .text. Would you like to print the file? Testing. And finished, and here you go. Test.txt exists and has testing written inside of it. So, one thing to keep in mind with Java file input and output is that you want to be very careful with the size of the file. In general, things like configuration files, things like most logs and stuff won't have issues. However, many files for things like, say perhaps logs for a gaming server, Minecraft, things like that, if the log file or whatever kind of text file you're reading from or writing to gets too large, it can cause some lag issues. And generally not as much with file output. File output doesn't look at the whole file really, but file input can become a problem. If you're reading from a file that's 10 gigabytes, it's going to say error, run out of virtual memory, and that's because the JVM has a certain amount of memory allocated to it. By default, you can increase that by using something like a .bat file to launch your application, but you don't want users to have to do that for most things. So just keep in mind to keep the file sizes fairly small. You don't have to go crazy, oh, it's over a kilobyte, split into the next file. Megabytes, hundreds of megabytes are even generally fine. However, they will sometimes cause some lag and whatnot, but file and different systems, Windows and I think actually Solaris doesn't allocate much memory to the JVM by default. So just be careful with your file sizes. Make sure they don't get too big unless you're intending for them to get big, or your application has some kind of dynamic way of reading from the file that doesn't impact performance based on the size of the file. And I think that's about it. The way Minecraft servers get away with it, by the way, a bucket server, for example, it doesn't read from the log. It only writes to the log. And so it doesn't have memory issues because it's not reading in the file. It's just spitting out stuff to the file, so it doesn't have a memory issue. However, if it was trying to read that log file, I think one of my servers like 250, 300 megabytes, and I've deleted it like 2 times or renamed it and moved it somewhere else, so it's not a thing that I have to keep backing up when I do server backups. So anyway, thank you for joining us, or joining me. This was a quick tutorial on how to do file I/O. The source code will be linked to in the description as well. If you have any questions, please leave a comment below or send me a PM and I will try to help you. And stay tuned for tutorial number 7 coming out very soon, which will be about making and launching .bat files from Java. And similar things apply to other kind of operating systems.